Hello adventurer, welcome to Strash Quest. Today is day 7 of Digital Logic section in Take from Zero series, and today we'll learn about K-map. So let's start. Before we jump right into K-map, I want you to visualize something. Visualize you are an engineer and you are building, for example, robot or something. While building a robot, you use different board or something like that, and you definitely use logic gate and stuff like that. You look at the logic gates. There is bunch of wires tangled to each other, bunch of logic gates. You are tired of it. Now you need to sort on it so that logic gates get smaller and your bank doesn't get zero. So your first step is obviously using Boolean expression, right? Well, you use the Boolean expression, but wait, you did a mistake in Boolean expression. You didn't use distributed law. You didn't use De Morgan law. Oh no, your whole project, your whole thing is gone. That's the huge disadvantage of Boolean expression. Yes, it shortens your it shortens your logic gates. It helps you solve the logic circuits to small. But if you did one mistake, all the progress is gone. That's where Keymap comes to place. Keymap does same tasks as Boolean expression but visually. Now let's just understand how Keymap is made. So the first thing is understanding what Keymap box is, how to make the box. So Keymap box looks like this. Here you can see different types of box. Here there is four gaps at four boxes. There is lot of boxes. So in a square you put different type of boxes based on the input. So in our logic circuits there are different input we put. There can be 2 input, 3 input, 4 input and so on. But in Keymap there is a rule. There can only be 6 input in Keymap. We'll understand why later on. So according to the variable or input, the boxes increases. If there is 2 input, we use the formula 2n. So 2 is the fixed position. In a n, if there is 2 input, we use 2 by 2 power 2, which say 4 boxes. If there is 4 input, it is 2 to the power 4, 16 boxes. We use this formula to determine how many boxes to put, as it is a possible combination. We do the same for the truth table. If there is 2 possible combination, there is if there is 2 input, there is 4 possible combination. Just like in truth table, we use it for making the boxes. For the Keymap of 2 variable is this. Keymap of 4 variable is this. In this video we'll learn up to 4 boxes, as 5 variable and 6 boxes variable is much more complex. Today we'll just learn the basics of this Keymap. So we'll limit ourselves to 4 variable. Now we know how the boxes is made. The amount of variable is amount of boxes. Now let's see how numbering works inside the Keymap, as all the things happens according to the number. At first is the 0 and it increases by 1 bit, so 1 and 1. Now let's see for 3 variables. Here it is a and b, here it is a, b and c. Remember this rule that if there is a variable, if there is a lot of variable, as you can see here, a, b, c or d there, you put the first variable in below and the later variable like c and d at the top. We use the first variable as row and second variable as column. We'll understand this much more in detail. I will come right away. So let's first understand the numbering first. So here, as the 2 variable, we first use 0 and 1. As a is alone, we just use 0 and 1. There is b and c, so we use 0 0 to denote this denotes b 0, this denotes c 0. Here it is 0 1. Now if you know binary, Here it would be 10, but we are using 11, and then here it comes 10, as we are using Gray code in here. Gray code is basically same as binary, but it changes by 1 bit. As the error, it is done to avoid the error. Let's understand the numbering much more. So we'll understand the numbering a lot with the 4 variable. As you can see here, there is 2, 4 and 4 variable. As we have said the rule, the first variable, the first a and b should be kept in here in the row, and the other should be kept in the top. We do this because computer reads from left to right, so it organizes the data like in left to right. These boxes you see here is like a box in the ROM and box of the ROM and RAM or the memory, and computer puts the value in of ABCD just like in here, just like it reads from left to right. That's why we put AB in the row side and CD in the column side. Obviously you can put CD and AB, CD in the row and AB at the column, as it can be done, but the numbering changes a lot. If you are doing exam or if you are making a key map, it's a lot easier to put AB in the row side and CD in the top side, or the front one at the row side and the top one the other half at the top side, or the column side, as the numbering is fits right away. So let's say if the numbering is we put AB at the row and CD at the column. Here numbering works like 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14. Here you may have noticed something. The numbering seems questionable. It goes from 1, 0, 1, 3, not 2 but 3, then only then it becomes 2. Again 4, 5, it is not 6 and 7 but 7 and 6. And on the line you can even see more crazier thing, that it is 12, 13, 15, 14 rather than 8, 9, 11, 10. Why is that? Well, it is the same reason, because of Gray code. Even in previous in variables where 3 and 4, we did the same thing. We use 0, 1, 3, 2 rather than 2 and 3, and 4, 5, 7 and 6 rather than 6 and 7. Why is that? Well, basically Gray code. In here it is due to this thing, 0 and 0. So as we said, it becomes 0, 0, 0, 1. Rather than writing 1, 0, we are using 1 and 1. In computer, it is 1 and 0. The memory, in memory, imagine this as a memory card. In the memory, it is 1 and 0. But for us human, to make easier to make the key map, we put 1 and 1 at front. But computer still reads this box as 2. This box as 2. So how do we prevent that? By flipping the number 2. Remember, this key map is human made. We human have made it. It is like a pictorial representation of a memory card. So in here, what we did was we replaced or switched the number 2. So as it becomes 1, 1, 1 in here, we put the 1, 1 value at here. So if 1 and 1 was in here, it would be 0, 1, 2, 3. But as 1 and 1 has come in front, it has become 0, 1, 2, 3, 0, 3, 2, 4, 5, 7, 6. Similarly in here too, in this row column, you can also see here we have put 11 at first and 10 at last, as we have done here, just like what we did at top. And here we also flip the number in 11 and 10. But what if we put CD as a row and AB as a column? It is not that we cannot do that. Yes, we can do that, but we must remember how numbering works. Remember what we did in 1 and 1 and 1 and 0. Just like what we did was we put the numbering of 1 and 1 in as it was, so as it would be 0, 1, 2, 3, but as the number changed from 1 and 0 to 1 and 1, we change the numbering 2, so it becomes 0, 1, 2, 3. 0, 1, 3, 2. Similarly, as CD becomes rows and AD becomes column, so does the numbering. So the numbering, as you can see here, it becomes just the opposite. It has become horizontal, so it has become 0 1 3 2, same as 2 3, but 3 2 4 5 7 6 12 13 14 15 14 9 8 9 11 10, same as before, but the numbering has changed. Here it is same as 0 1 1 0, sorry 1 1 1 0 0 0 0 1 1 1 1 0. It is same as that, but as we change the column to rows and rows to column, so did the number. I hope you understand this concept of numbering. Before we move on more, I want to understand about the how this numbering is really. So this, when we say 0 and 0, we are saying A complement B complement. We are representing A complement B complement. When we say 0 and 1, we are saying A complement B. 1 represents positive and 0 represents the negative. So when you say 1 and 1, we are saying A and B, positive and positive. When you say 1 and 0, we are saying A and B complement. When you say 0 and 0, we are saying A complement and B complement. Sorry, C complement and D complement. AB is this, CD is this line. So now we know how box is made. Now let's learn how to fill the box. Now to fill the box, which we have made just recently, we need to understand about these two terms, SOP and POS, sum of product and product of sum. So it looks like this. This is sum of product and product of sum. This SOP is known as a half full approach and POS is known as half empty approach. As SOP means to look at the 1 and POS means to look at the 0. Let's see a truth table here. In the truth table, this you see 0 1 1 0 0 0 1 0, and this is the output. When making a Boolean expression, what we did was we look at the 1 and made a Boolean expression. That is SOP. That's what we are doing in KMap. In POS, what we do is, rather than looking at 0, we look at rather than looking at 1, we look at 0. So SOP is just looking at 1 and making the expression out of it, whereas POS is just looking at the 0. But as you go on, POS is not really important that much, so we'll just be focusing on SOP for now. Now SOP rules are here: to focus on 1, grouping, and chains, to look at the chains. At first it looks confusing, but as we go on, we'll understand it. Let's make first of all make a KMap of 2 variables. Let's say the first of all a truth table, A and B with output. As there is 2 variables, there will be 4 output: 0 0 0 0 1 1 1 0 0 1 and 1 1. That is our truth table. Now let's make first of all Boolean expression of this. First of all, to make a Boolean expression, we use SOP form. If we were using the POS form, we look at 0. As we are looking at 1, we look at 1 and say 1 and 1, which is A complement B plus A B. Now can we shorten it? We can either use the Boolean expression or the KMap. KMap is obviously easy, so we use the KMap. We have the 2 variables. We put the first variable at the row and this at the column. So we put the numbering 0 1 2 3 0 1 0 1. As you can see here, the value or the numbering doesn't change. We put it as it is, 0 1 2 3. Now let's put the 1 and 0 as a truth table. 0 0 gives us 0. 0 and 1 gives us 0, 0. This A0 and B1. A0 and B1 gives us 1. Then 1 A1, which is this, and B0, which is this, gives us 0. Whereas A1 and B1 gives us, which is this and this, gives us 1. This is filling the K-map. This is how we fill it, the K-map. Now comes the rules of grouping. First rule we have done it, which is focusing on one. What we can do is just focus on one, and let's look at 1 and say 0 and 1, 0 1, and just put 0 in other two. We have done the first task. Now let's learn the rule of grouping. The grouping rule tells us these following rules. The first rule is it must be grouped in a power of 2. So these are 1, 2, 4, 6 and 8. These are the power of 2. So it must be grouped in a power of 2. That's the first rule. The second rule tells us it must be grouped in this way. It cannot be grouped in a crisscross way, just in straight and in vertical, not horizontal. So in here, as you can see in a box, the first rule tells us it must be grouped in group of 2, 4 or 6. If there is 4 group, we prioritize 4. If there is 2 group, we prioritize 2. So let's say all of these were 1. If all of these were 1, we don't group by 2 group and 2 group. We group them as 4 group as a whole. So if there were all of them were for 1, we group all of them as 4 as one whole. But as there is only 2 1, we just group the 2 of them. We prioritize the higher number. If there is 4 as a whole, we prioritize 4. If there is 6 as a whole, we prioritize the 6. We'll understand this as we go to the higher variables. And the second rule, that is, we cannot group for this crisscross. Let's say instead of 1 in here, there was 1 in here. Now we could not group these two. That's the rule. We cannot group them like this. We can only group them like 1 and 1 here, or if there was 1 and 1 in here, we can group them like this. That's the another rule. The another very confusing but a really good rule is, let's say if there was a box. In a box, there is a lot of box in here too. If there were a box in here and here, we could group them. Why? As this K-map is like a toilet paper or a circle. It comes down as a whole. So this upper part and this lower part can be considered as the same part, as it is considered as a row. So it is connected. Same with this side and this side. Same and with this side and this side. Let's say if there were 1 in all of these each side, these could group as a group of 4. That's an interesting thing about K-map, which seems confusing at first, but as we go on and do questions, it gets easier and easier. Now let's do questions of 4 variables or 6 variables or 3 variables. Let's say we have let's wait a minute, I'll get a question. Let's say I have a question. Let's say I have 3 variables, A, B and C, with output. First, let's draw all the possible outcome in the truth table. 0 0 1 0, let's say 0 1 0 gives 1, 0 1 1 gives 0, 0 1 0 0 gives 1, 1 0 1 gives us 1, 1 1 0 gives us 1, 1 1 1 gives us 0. Now let's make K-map of this. Obviously we can make a Boolean expression of this, but K-map is easier. This is obviously the previous questions. Now K-map. There is 3 variable question, as we have said in previous. We must put the later half in the upper part and the first half in the row part. So we must put A in here, but as it is B, there is uneven part, we put uneven part in. So B and C in here. It is 2, as it is single, we put 0 and 1 in here. This is B and C, so 2 3. As 2 to the power 3, it tells us to make 8 groups. So let's see, 0, it is 0 0 0 1 1 0, sorry, 1 and 1 and 1 and 0. So it is 1 3 2 4 5 7 and 6. This is the number. Now let's put the 1 in where it is. Rather than filling each and every gap, we just say the 1. Where is the 1? So let's draw the key map here, looking at the truth table. The thing, as first we see here, when A is 0, B is 0 and C is 0. When A is 0, B and 0 and C is 0, it is 0. Now we can fill each of the boxes using C as the truth table, but it would be boring. We'll just look at the one, that is yes or B. We look at where the first one is. Here it says when A is 0, B is 1 and C is 0. So when A is 0, so in this time, this row, and B is 1, B is 1 and C is 0. So in here it says when it is the condition, when A is 0, this is this line, and B is 1 and C is 0. So obviously in here, so it is 1 in here. This is done. Let's look at this. When it is 1 0 0, when A is 1 and other is 0, so in here when A is 1 and B is 0 and C is 1, so in here when A and B is 1 and C is 0, when A and B is 0, or in here, and other is 0. Now as you can see here inside, I have done the numbering. If you like to look at the numbering, we can also do that. So let's say 0 1 2, sorry, 3 2 4 5 7 6. Let's fill the number looking at this number sign, and see if it is correct or not. For 0 it is 0, obviously. For 3 it is 0, 3 it is 0, correct. For 5 it is 1, for 5 it is 1. So yeah, this is why numbering is also important. We did the thing of grouping or putting the one. Now let's group them. As a rule, we must group them in a group of 2 group of 2 4 or 6. As there is, okay, first of all let's see if there is group of 4 in here. No. Then is there a group of 6 in here? No. Then we look at the lowest term, that is group of 2. Let's group it. So 1 and 1 and 1 and 1. When grouping, after grouping, we get the another rule, that is changing. So here A is 1 for A is 1, there is no change. Here there is no change, so it becomes A. In B and C there is change. Here B has changed from 0 to 0, there is no change, but C has changed from 0 to 1. If there is change, don't put it. If there is no change, put it. But B hasn't changed, to put B. But as B is 0, we put complemented put top. If it was 1, if B was 1 and it changed to 1, then it would just be B. But as it changed from 0 to as it didn't change from 0, it becomes B complement. Similarly, is 1 and here E has changed. E has become 0 from 0 to 1. So we don't include Y. But B and C remain same. But B is positive and C is negative. So it becomes B and C. So answer is EB complement plus BC complement. So today in our video we discuss about what K-map is, what are the rules, how to make a K-map and why we need it. In next video we will discuss the K-map much more deeper, doing much more another examples of 4 variables, 3 variables, but for today this is it.